My PhD thesis was about modeling seismic energy transfer on a flat Earth. Can produce absolute evidence that that's what happened. I'm not going to believe you.
Hey, drunk guy.
The isolation, I don't know who you're referring to with the phrase drunk guy. There's no drunk guy here.
You're not drunk?
To my knowledge. No.
You're doing this sober?
Yeah.
That answers a lot of questions I have. All right. Carry on.
This is the guy that told Blue that he was the earthquake.
Imagination is all you need.
I am not your grandmother.
Don't take advice from fools. Everything that they say is in vain.
No, because,
never take advice from fools. We all know what they do is in vain.
Again, if I'm really triggered, you'll be able to hear because I'll be yelling it. It sounds more like this! It sounds more like this! There you go. Now you can tell the difference. I'm not angry. There you go. Now you can tell the difference. I'm not angry.
Everything is relative to you. You just have to say it in generalities. Just like those straight lines are curving.
No, because,
drive down the road, don't you ever swerve. And I don't know.
Define the term horizontals.
Where all of this goes.
Like more than one.
Never take advice from fools. 'Cause everything that they say is in vain. Never take advice from fools. 'Cause everything that they do is in vain.
You model flat Earth models. Right?
I have done, but at the moment what I do is
were they accurate?
They were accurate as to the they were ultimately accurate, yes.
I know the game that you're playing, and I know exactly what's on your mind. You got your playbook, it's alright.
The pressure waves from the Krakatoa experiment.
You will find, and I don't
you expressed dismay and confusion
where all of this goes.
that a sphere is a two-dimensional object.
Don't take advice from fools. 'Cause everything that they say is in vain. Never take advice from fools. We all know what
If you turn, imagine two planes.
So the great circle isn't a straight line now then. It's a circle.
A great circle is a circle, hence the name circle. It represents the shortest, so the shortest path between any 2 points on the surface of a sphere will coincide to an arc along a great circle.
You model flat Earth models, right?
I have done, but at the moment what I do is
were they accurate?
They were accurate as to the they were ultimately accurate, yes.
3 angles.
You don't have a triangle on a sphere, though, sir. You do realise that.
That's exactly right. They don't get 180 degrees. They always get more than 180 degrees. Which is what you would expect on a spheroidal Earth. Yes, that's not a triangle, but it is 3 points. I have a PhD. I have also represented my country multiple occasions in mine sports. Please believe me, you are wrong.
Tony has a PhD. Literally works with gravity and stuff. So he was talking about triangles being greater than 180. Would you like to question him about that?
Yes, straight line, point to point.
Mm-hmm.
Yeah, and you add up the observed angles, you get more than 180 degrees. You're measuring the angles and then you add them up. I have already explained the distinction between flat Earth and spherical triangles.
And every single one of the triangles were over 180 degrees.
Yes,
and
I'm a
didn't
bit
answer the
confused. So let me get this straight. So you're abusing here the term straight. On multidimensional surfaces, straight corresponds to what's called a geodesic. But that may not be straight in a different frame of reference. Straight according to the surface that you're on. You know, what is called straight line distance on Earth's surface are actually curved arcs. They are straight with respect to the Earth's curved surface. They are the lines of minimum distance. They are the geodesics. You're a flat earther. What's your reference frame? I called you a flat earther. And they add up to more than 180 degrees again. A fluid of any sort adopts a geometry in response to the forces that are applied to it. We have two hypotheses. One hypothesis is that the Earth is a sphere, and the other hypothesis is that the Earth is flat. You're insisting that your flat Earth geometry will work in every circumstance. The vertical means in the opposite direction in which things fall. Yes, vertical means up. You know, they're always perpendicular to one another, but what I consider to be vertical, you don't consider to be vertical.
On a circle, on a sphere, okay, the plumbs become offset.
Like, how do you measure your offset?
It's determined by the radius of the Earth and the distance that from point 1 to point 2.
No. They're perpendicular to different horizontals. It's horizontal everywhere. The horizontal at one position can be orthogonal to horizontal at another position. Yes. No.
Go on, what do you think?
Okay.
So imagine you have a
take 3 points equidistant on the equator and draw a line between each one of them. That is essentially a triangle.
Yes, and this is basic. This is
geometry.
Yes, this is basic geometry. This is basic geometry.
It is. Yes, what an angle is.
You're demonstrating you have no idea
what
basic geometry is.
Each of which is 180 degrees. What's 3 times 180? Yes, we have three angles of 180 degrees.
That's a straight line, right?
Well, so if you what you describe as geometry and what I mean geometry are actually very different things. That's right. But any 3 points placed on that surface.
It is literally a small set of continuously straight lines that are going around a curved surface.
So Bill, I'm not going to bet you on this one. I think you got a very good chance that no, Randy's not going to go up there and do
my
this.
prediction beat everybody else's. Yeah.
But anyways, take care.
Yeah, take care, man.
We can demonstrate that the Earth is not flat, level, that it is a spheroid, right? Without any appeal to optical evidence.
Okay.
You guys know that, right?
Yes.
Any seismologist can do this, right? You can take earthquake signals from the thousands of seismic stations we have around the Earth,
or B-balls,
and we
Cavendish.
can examine. And
Blues,
we can
Cavendish.
and we can analyze the. So you seem to be slightly confused there, Bev. If a building falls over because it's been hit by a seismic event, does that turn it into a seismometer?
Sorry?
You'll have to let me know which part of the question confuses you. I'll repeat it for you. If a building falls over because it's been hit by a seismic event, does that make the building a seismometer?
I don't know. It would be wrecked, right?
It's a yes or no question.
What would it record it
on? Listen to the question and answer it. It's just yes or no.
Well,
Does a building suddenly become a seismometer if a seismic event hits it and reduces it to rubble?
Doesn't a seismometer record the event though? That's the whole point.
So, yes. So my question is, does the building
is that a recording of
is
the
that
event?
You seem to have trouble with the concept of questions. I'm asking you a question and you're not answering it. You're not responding to it.
You want me to answer it in a way that you do.
Is it a yes or no question? Just say yes or no.
No, because I can't. How can I do that? What's a seismometer?
A seismometer is an instrument that records seismic events, records the intensity of seismic fluctuations.
And you're asking me, is a building one of those?
Is a building that is impacted by a seismic event a seismometer?
You just said a seismometer records.
Yeah, that's what I said. It documents it.
Okay, so it's a simple yes or no fucking question, isn't it?
Why would you even ask that question is the point? It's a stupid fucking question.
You defined a size...
Because just because a Blues-Cavendish experiment experiences a seismic vibration does not make it a seismometer.
Blue thought it did.
No, what Blue said was that the observations he had were influenced by a seismic event. That's what Blue said. Blue did not say that he could that he had an accurate recording of the frequency domain of the waves as they went past, nor does he have a northeast and up down, north south east west up down dissection of the seismic wave as it comes through. So no, it's not a seismometer.
Well, you just said a seismometer was recording something, so he was recording.
It was recorded on camera, so all you have to do is put a camera.
No. So if I put a camera, if I put a camera in front of a building, does it suddenly become a seismometer? No. Your argument is fatuous gibberish.
Oh.
If the building had a Cavendish machine in it, it might.
No, it doesn't suddenly become a seismometer.
If a seismometer records it, and that's what that did, it recorded, I don't see the problem.
Well,
it might be a very fundamental
That's more of an indictment on your ability to understand what an actual recording is.
Yeah, go and attack me as a person then. Yeah, go and attack me. Go on.
Wait,
try not stay. Try, in order.
No. How about you try to not just be a prick? That'd be good.
Who told Blue
How about
he
you
was
try
detecting?
not to be an idiot? Don't say idiotic things, and I won't call you an idiot. How about we go with that?
You said a seismometer records seismic events. This thing recorded a seismic event. So who is the moron here?
No, it didn't. It recorded the influence of a seismic event on a structure.
So Blue said it recorded.
I'm not interested in your characterization of what Blue said. What Blue said was the instrument vibrated due to a passing seismic event. I vibrate when seismic events go past. You vibrate when seismic events go past. Does that turn you into a seismometer?
I don't record it.
Who told Blue he recorded a earthquake?
That would have been, the person who did that would have been a person from the U.S. Geological Society's seismology section.
Oh.
So he sent the data to them and asked them, does it look like this influence on this machine is due to a passing seismic event?
Oh, what
did they say? Said yes. Yeah, they said yes, it looks like it very much does. That's very cool. Thank you for asking.
Oh, so it turned it into a seismometer.
What they're doing is a straw man.
No, it's not a seismometer at all.
Exactly.
But it recorded a seismic event.
No, it did not. It experienced the influence of a seismic event that in no sense turns it into a seismometer any more than a car vibrating and the alarm going off.
But he recorded it.
That.
And then said,
in order
that's a seismic event.
Okay, so let me ask another question. If I have a tape measure and the tape measure flexes due to the influence of gravity, does that turn the tape measure into a gravimeter?
Your measurement would be
if
off.
it's got a way of then measuring it and recording it, yes. Just like the Cavendish has a way of measuring the shaking and recording the shaking.
Except it isn't measuring the shaking, is it?
What isn't?
You can't tell the amplitude.
What the hell's it measuring then?
It's measuring
the shaky that said the room was moving.
Oh my goodness, this is just nonsense.
Will you shut up long enough to listen?
Ooh.
It was measuring the
Yourself,
frequency.
dude.
It was measuring the frequency.
Are you rude? Did your mama not teach you manners?
Blue server. We're sorry for that. I don't think
Blue. Did your mama not teach you manners?
Don't think Blue does this around here.
No, a simple no would have done that. Right?
If Blue was here, I'll stick up for Blue. If Blue doesn't like that sort of stuff.
It measures the frequency of the. It measures the frequency with which the seismic energy passed. It did not measure the amplitude. It did not measure the different various components of it.
Yeah.
Nor was it integrated with the time system that the international seismic stations require.
Yeah, you know what was really cool?
Big deal. It's a basic one. Big deal. It still did it. Still.
What was cool about it is not that it picked up an earthquake, is that it picked it up so slightly because it was so far away, showing just how sensitive those pendulums are.
I don't understand. I don't understand the basis of your claim here. So this instrument was shaken by an external phenomenon. That does not change the nature of the instrument any more than a car that is shaken by a seismic event and has its alarm go off suddenly is no longer a car, right? Seismic events have a physical phenomenon on objects, right? But that doesn't change. And some of these objects have the capacity to detect and register those events. A modern car, for instance, with a sophisticated alarm, can detect a large enough seismic events, the alarm will go off, and it will relay that to a control station. That does not make a car a seismometer in any meaningful sense.
No, it doesn't, but it becomes a basic one, doesn't it? It becomes a warning system it becomes a way of knowing that has happened because it's recorded a shaking event. Doesn't matter how basically it's done it. It's done it.
So, yes, physical objects are influenced by seismic waves. What's your point?
That's our point
with his, that it can be influenced by size. That's our point.
Yeah, I thought Cavendish was supposed to isolate.
But, you can isolate as best you can, but while you've got an observational station that is in connection, can you point to any other events
from moving?
It's not the walls that are important.
That's
it's
what
the
floor,
floor, right?
It was the whole thing was moving the walls and everything. Blue was adamant.
Yes, but the walls won't influence the instrument. It's the floor that influences the instrument, right?
But it wasn't. That's what they weren't saying. They said it was that well isolated that it was the walls that were moving.
Can you stop pretending that you understand what other people say? Because you don't.
Well,
okay?
I was just telling you what Blue said.
No, you said that Blue said that I told him it was an earthquake. That's false. I didn't tell him it was an earthquake. He asked me if it was possible. I said it was. It sounded to me like it was possible. But he should actually go talk to a specialist seismologist, which is what he did, because I don't presume to comment on scientific fields in which I am not an authority. And so I suggested that he should go and talk to somebody. And you came up and told me, well, Blue said that you said it was an earthquake. I said
that's
no
what
such thing.
he said.
Blue did not say that. Blue said he talked to me about it, and then he went and talked away to USGS.
He said you said to him it might be the earthquake.
Yes, and I did say it might be an earthquake. I didn't say that it was an earthquake. No, you said it. Actually, I wasn't. He came and asked me, do you think this is an earthquake? It might be. Somebody else said that it could be an earthquake in the live chat if you'd bothered to watch the footage of the event. Somebody else in the live chat said, well, did you notice that there was an earthquake in Haiti? And then Blue came, and so somebody else suggested it to him. He came to me, and I said, well, it's possible. Go and ask an expert. I did not say that it was an earthquake.
Did I just walk into the girls' toilets at a high school or something? I'm having really bad flashbacks.
I don't know what your interpretation of your surrounding is. Please don't ask me to speculate.
Wow.
I am
the way you're
commenting. I am commenting on Bev's reliability when he says that so-and-so said this.
Dude, you sound like you're about to lose your mind.
You probably have that effect on a lot of people. I'm just more reflective of it.
3 coplanar points.
No, if you want to keep on trading the personal barbs here, if you want to keep on trading the personal barbs here, I'm more than happy to oblige you.
Yeah, that's really what you want, right?
But what Bev? But
Sorry,
Bev,
was that
when
a
you
barb?
say,
I didn't realise.
when you say, Blue said this, almost certainly, unless you can produce absolute evidence that that's what happened, I'm not going to believe you.
Hey, drunk guy.
The isolation, I don't know who you're referring to with the phrase drunk guy. There's no drunk guy here.
You're not drunk?
To my knowledge. No.
You're doing this sober?
Yeah.
Well, that answers a lot of questions I have. All right. Carry on, man.
This is the guy that told Blue that he was the earthquake.
Is he a table banger?
I think so.
No,
Do you have any valuables on your table at this time?
I didn't tell define valuables.
You don't have anything
What is
breakable
this
on your
question?
table, right?
I
hope
yes, I do. But,
be careful.
Well,
don't
I
bang
am
the table too hard.
I am typically careful, but thank you for your concern.
But be very careful.
Let's go back to what I was saying. We can look at the propagation
the thing
of
you've said
seismic
like
energy.
100 times so far, sober guy.
Propagation of seismic energy across the Earth, and we can look at the way seismic energy propagates across the world, and we can use actual reliable seismometers that are set up in arrays, that are set up in extended networks, that are all connected to one another with timekeeping devices, and each individual seismometer records the north, south, east, west, and up-down vibrations for each seismic event that it detects, and it can detect multiple phases of earthquakes arriving, and we can detect the propagation of this energy around the world, and we can see seismic energy go from one side of Antarctica to the other side of Antarctica without going anywhere near before it's had time to get to the equator. And we can see this happening, and we can see this happening for small earthquakes that don't even get energy. So this demonstrates, we can tell from seismic wave times, seismic travel times, that the Earth is spheroidal, because it's the only geometry for which this is always the case, that energy radiates out in a circle. Did Blues Cavendish do that? Blues Cavendish did not demonstrate that the Earth is spheroidal. No.
It's called a bonus.
It's a Cavendish Plus, that's what I'm calling it.
I couldn't care less what you decide.
It's a
Cavendish.
We saw it.
It's the Cavendish multi-tool.
This is a vain attempt to get people who don't understand and don't know about seismic evidence to suddenly start realizing that seismic evidence is a thing, and if they want a model of the Earth that works, they're going to have to explain it. We can tell that seismic energy does not reflect off the edge of the Earth, right? There's no boundary at the edge that reflects seismic energy in. And if there is no boundary off the edge of the Earth, then you have to explain why it is that Rayleigh waves, which are a special type of surface wave, there are two types of surface waves, Rayleigh waves and love waves. Yeah. How do Rayleigh waves manage to make multiple orbits around the Earth?
Huge straw man.
Multiple circuits of the Earth. Rayleigh waves, if you're going to let me finish, Rayleigh waves make multiple circuits around the Earth, back to their point of origin, and then around again. And they do so in a fashion that is completely inconsistent with the Earth being flat. With
like
the
a
Earth
540-degree triangle, right?
Well, the Earth must be completely spheroidal. I know you're trying to derail the conversation and turn it into something.
No, you just said it was flat.
Something else.
So does Cavendish
pick up Rayleigh waves? Inconsistent. Yes, yes. The Earth, the Cavendish experiment picked up Rayleigh waves. Yes.
Right.
The sound wave from Krakatoa went around the Earth several times too, or no, a few times, 3 or 4 minimum.
The signal was picked up about 7 times at different stations. Yes, that was the pressure wave from the Krakatoa experiment, and again, it propagated in ways that are completely inconsistent with the Earth being flat. Right, the Earth must be spheroidal to explain the propagation of the pressure wave from Krakatoa, because you see the wave. Yes, it must, because you see the wave come from the source, from Krakatoa towards you. How about
pressure waves?
You listen rather than just blanket dismiss it.
Sorry.
You detect the pressure wave. You detect the pressure wave. You detect the pressure wave coming towards you from Krakatoa, and then a little while later, how much later depends on how far you are away from Krakatoa, you'll see a pressure wave coming from exactly the opposite direction, from behind you, as far as Krakatoa is concerned. And that wave is the wave that Krakatoa sent out that has gone around the world and has come up behind you. And the wave that you saw the first time coming from Krakatoa will go around the world and it'll come back again. And the wave that went past you from behind, that'll go around the world and come back. How do you explain that on a flat Earth? And Rayleigh waves do exactly the same thing for every large enough earthquake.
I've seen modelling of the Mercator map with earthquake. Earthquake propagation going in circles, 2 sort of circles, like a figure 8. But
no, you haven't.
Okay.
Well, if you have, then it was fallacious. I can tell you that I work with professional seismologists. In fact, some of the greatest seismologists on the face of the planet. If we're going to be honest, and the propagation of seismic energy.
And all you needed was for that wave to come around from the back and hit you again. And I said, I've seen that be modelled. So.
Yeah.
Well, not by any reputable. Did it bounce off anything?
Of course not. Your science people agree with you. So of course you're not going to think anyone on our side is reputable. So it's not going to matter, is it? It's never going to matter.
We're the ones who get, the scientists on my side of the argument are the ones who get who get asked to set up the tsunami early warning system, or the earthquake or earthquake resistance programs, or structural design.
And I'm
programs.
Sure if other models started getting looked at, you could probably do the same thing with them as
well. It turns out, luckily for you, all seismic data is available in a public record. So you can download all of the seismic
Well,
data,
that's
and
probably
you
how
can
they
start.
did the model then, isn't it, sweetheart? Get all that data and they modelled it on their flat plane.
Paige, we
Well,
like,
you're
can we
going to
bring
have
it back to blues?
you're going to have to show me the reference for that and the journal that it was published in, aren't you?
Why? All you asked for was, has it been modelled on a flat plane?
No, I didn't ask that at all. I said, how do you
sorry,
explain
you said
it on a...
I
I said,
done on a flat plane.
yes,
What did Blue
yes,
model it
and that's
on?
because... And
I said I've seen it modelled on a flat plane.
Blue
so
didn't... Well, my PhD thesis was about modelling seismic energy transfer on a flat Earth.
Wonderful.
And
In
I'm
a Cavendish.
going to tell you that whoever...
They're using the
no,
same
that's
data
an idiotic question, Bev.
No,
it
you
isn't.
can't even stop
It's
talking long
nonsense.
enough for anyone to answer you. You're so triggered. Do you even breathe?
I'm not triggered. I do breathe.
You are.
Thank you very much for
won't
asking.
Even slow down.
No, because, what you're saying...
Your voice is higher than mine at the moment, darling.
You can't... Please don't call me that. Whoa. It really does disgust me. But please,
Come on, Tony.
I can tell you,
You're triggered, dude.
Yeah, I would assume anyone showing him any kind of kindness would disgust him. That does not surprise me at all.
It would not be appropriate for me to go around calling women darling or love. And it's not appropriate when...
Oh, we get called love here. My grandma calls me love. My granddad called me love. It's pet. Those names here are very common.
I am not your grandmother or your grandfather, and
You don't have to be even more triggered about it. Like, if you can't handle somebody being nice, not a problem. I won't be.
I don't consider the word darling to be nice. And I don't think you were trying to be nice. I think you were trying to be condescending.
Wow. So now you were just going to change the meaning of every word.
Yeah.
So now if you go, yeah, no worries, bro. That's now nasty.
No, I didn't say it was nasty.
Mate, if I said, yeah, okay, mate, whatever you say, mate, another common word we use for...
Yep. Who's we in that statement?
Is that going to be Australians?
Okay, I'm Australian. I'm Australian, you know that, right?
You don't act it.
So I know that most Australians don't use darling.
Rubbish.
Right?
Do you know most Australians? How many? Do you know most Australians?
Maybe the ones with their heads so far up their butt that they spend all their day watching, American and English mainstream media shit. Maybe those people don't say these things anymore, but just, normal down-to-earth people who are still, trying to connect.
Let's go back
and
to
not
my
just
question.
scream at others and force them into their beliefs.
My question was...
Yeah, it does have the opposite
meaning.
meaning.
Yeah, your question.
My question was, how do you explain it on a flat Earth? And the fact that you said you've seen it modelled doesn't answer my question. I want to see
I said it's
that
two circles
model.
To go around. Well, then go and look at it. Fuck me.
You haven't given I asked you for a reference for it, and you told so that I could go and look at it, and you told me.
Okay, can you type into YouTube? I'll give you the letters. You ready? F P V. Oh, well, there you go. Bad luck.
Well, there you go. Okay, so you can't produce a model that explains it. Good work.
Have you ever talked to FPV, Angel? Tony? We can get FPV Angel.
Of course he won't.
We can get you a chat with him if you want. FPV Angel.
Don't know who that is.
Well, you want to see a model, right?
The guy with the model. I was trying to give you the reference you wanted, and you wouldn't hear it.
Mm-hmm.
And my phone shuts down if I try and get a link. If I try and open YouTube or something, my phone just shits itself and shuts down.
Yeah, I can send him
I can't get an actual physical link for you.
You can send him to
But yeah, I tried to give it to you by voice. You didn't want to take.
No, I don't. If you can't be, if you guys,
because
I'm not
interested, you don't want.
and I'm not interested, and I'm not interested in.
You won't take.
Well,
really,
I'm asking for a reference. I'm asking for a reference to a peer-reviewed journal. You're giving me a YouTube link.
How the hell are we supposed to have a peer-reviewed journal yet? Honestly,
Because you're claiming that it's scientifically
Get down
valid.
off your fucking pedestal, mate. Get out of your ivory tower. Come back down to reality. It's been, what, 6 years? Give us all a break.
No!
Give us $56 million a day and we'll do your
no,
fucking peer-reviewed journals for you. We'll just pay all our peers to write whatever fucking stories they want to write.
You can write it.
You people shit me.
You can submit it to. You can write a paper and you can submit it to a journal any day. You can do it any day. I'm not even angry.
Wow.
You're not angry? Oh my God.
No. That,
I'd like to see you when you're angry, dude.
It sounds more like this. There you go. Now you can tell the difference.
Wow.
I'm not angry.
Dude, there's something seriously wrong with you.
No, don't.
That from USC Montreal. You're the man whose voice I recognize because of the idiocy you were publicly spewing.
Isn't it?
You know, it is. It's a great voice. It doesn't sound like it would be attached to a brain that deficient, really.
Wow, and
But
you're a
there you
PhD.
go.
My God.
Yep.
They didn't teach you manners?
No. I
You didn't
extend
take the manners course?
No.
Okay,
surprisingly,
yeah, I can tell.
Not part of the course.
They didn't
So
teach you how to
what we-
properly speak to women where you come from?
Am I supposed to be treating women up differently from somewhere else? Because I thought that was sexist.
Yes, we're different to men, so yes, you treat us differently. Yes.
How do you want to be treated differently? In what fashion?
Well, we're different to you. We're not men, so yeah, you do talk differently to it. You should.
Should I? Why?
Because you're a man and I'm a woman. We're
I'm
different.
sure if your mother
And
was
I
around,
think-
she'd slap you one right now. A good slap.
Yeah, would you like anything to talk to your mother, call her a CUNT or talk about her PUSSY or something like that? Yeah, there is a point where we have to go, yes, we are different. We need to show each other certain levels of respect, and that depends on your gender, your age, all these things. You know, we respect the elderly. We open the door for older people. If somebody's older than you, you open the door, you say hello, you smile at elderly people, you know, all that kind of stuff. That's just basic fucking manners. Basic. You know, what you'd say around your mates when you're with a whole bunch of guys, you don't say in front of girls. Like,
so did I
stop making us all the fucking same. We're not.
So
I fucking hate it. I'm not a boy. I don't want to be treated like a boy.
Okay, so you don't want your statements assessed on their factual content. You want to be
I'd
assessed.
rather be just that.
Okay.
Rather than be personal attacks or anything about.
So here's my criteria. When I'm talking with somebody, I possess quite a bit of education and technical knowledge that is not available to the average person.
You're a snob. You're a technical snob, is what you are.
Yes.
I'm
yes,
sorry,
I
Tony,
am.
that doesn't impress me.
I am.
It just tells me you're more
then I
indoctrinated than anybody else and in need of more help than anybody else.
I'm not.
That's what it tells me.
I'm not actually. You know, you'd be surprised how little I care about what you guys think about me. You can think I'm rude. You can think I'm ignorant. You can think I'm stupid. You can think I'm brainwashed.
No, that's good.
But the
It's good that you don't care. You shouldn't let it get to you.
But the reality is that I am. Okay, I have objective measures. I have objective metrics that I can apply to measure this, to quantify it, to demonstrate it, right? And I have, as a result of my educational experience, access to evidence that you guys don't have. And what I am trying
to believe in the law of non-contradiction. PhD boy.
They can't demonstrate a water on a ball. In reality, they can't demonstrate gas pressure around sticking to this ball without a container. In reality, like the actual demonstration part of what you just said is non-existent.
That is untrue, right? You know that those statements are untrue because we can demonstrate the existence of gravity.
You've never made a proof of concept. You've never made a proof of concept with like what I can do. I can make you a proof of concept of a level plane with water on it, with air, pressurized air in it, with plants growing in it, with insects in it. That's my proof of concept to say to you, Tony, this is why I believe what I believe. This is why.
And
what can you do for me to give me in reality to tell me, here, Paige, this is why I believe what I believe?
Okay.
Can you do that for me?
Yes, I can.
Okay,
do you understand gravity, right? Do you understand how we know that mass attracts mass, right? It's
it's just down, just vertical, just down.
Okay.
Perpendicular to horizontal.
All right. So are you familiar with mineral exploration, that mining companies try and work out where to drill or dig mines in order to recover minerals from underneath?
To save your life, are you talking about gravity? Because I'll agree with you if you're going to claim an acceleration. I've got no problem with saying there's a downward acceleration.
No. Okay, that's not that's part of what I'm saying. That's part of what I'm saying.
Go ahead.
But please, okay.
Yes.
So mining companies want to have some idea of where there are good places to drill or dig and where there are bad places to drill and dig. And there are multiple techniques that they use for this purpose. And one of them is seismic surveying, right? There's also magnetotelluric surveying, but there's also a thing called gravimetric surveying, which is where you take a gravimeter and you measure the rate at, the downward acceleration of objects, test objects, in a region. And you can tell where the object falls faster, accelerates downward more rapidly, and where it accelerates downward more slowly. Now, if it accelerates downward more rapidly, that's an indication that there is more mass underneath the gravimeter at that point. And in fact, if we find an area with a gravity anomaly, perhaps it's high gravity because which we would interpret. Okay, let's leave it aside. We interpret these regions where there is more rapid gravitational acceleration. We interpret as a positive mass anomaly, and so we may want to know where is the mass. At what depth is the mass there? Because we can tell that there's more mass there, but we don't necessarily know how deep it is. And what we can do then is we can drill a thin hole and we can put a little gravimeter in the borehole, a borehole gravimeter, and we can send it down the borehole, and it'll tell us when it gets to the maximum the maximum density anomaly. So,
but on my model, that would just be the mass attracting it. The static pull, the model that we use with the density, the stuff the thing is made out of. So that whatever metal it is, it has a different pull, so it will affect this thing differently. So I'm not saying that you can't measure this different effect. So I'm just saying the explanation is different.
I worked in mining for many years, and they just drilled holes.
And I'm really sorry, I'm in the middle of a hurricane here too.
So, so if you look up gravimetric mineral exploration, you'll see that it is a technique that is used. There are geophysics companies that rely on it. Let's move. And what you say? Okay, so you're saying density attracts density, and Newtonian gravity doesn't have anything to do with it. Well, there's a particular form of gravimetric surveying called gravity gradiometry. And this was actually developed by the US military. Now, it turns out that we don't have very accurate maps of the ocean floor. I'll get onto that in a little bit because it's the third application of gravity that I want to discuss. And what submarines found was that they were at risk of running into obstructions because they just didn't know that they were there. And they preferred not to use sonar because every time they emit a little sonar blip, everybody would be able to hear where they were. So they wanted some technique for working out where these mountains were, where underwater obstructions were. And they developed what's called gravity gradiometry, where they use multiple instruments in a sort of a cube. They've got multiple accelerometers in sort of a cube. so they can calculate the gradients of gravity, the gradients in X, Y, and Z of the gravity field. And from the shape of these gravity gradients, so they work out the accelerations. Using Newton's law, they then use the gradients of those accelerations to tell them where the underwater obstruction is. Now, if Newton's law of gravity was not accurate, that technique wouldn't work. And this technique, gravity gradiometry, is now used by mineral mining companies as well. They measure the gravity gradients on the surface, and they can use that to locate mineral deposits. But the key thing is that, yes, you've got the observations, but in order to work out where the mass is, you need Newton's law of gravitation to be accurate. If it isn't accurate, then you're using the wrong theory on observations, and you won't get the right result. But we do get the right result, which suggests that the observations and the theory.
The oil companies wouldn't, and mineral companies wouldn't be making millions of dollars off of your tech.
Yeah.
Mind your P's and Q's.
The third. Yeah, money talks, bullshit walks. That's a popular Australian saying.
Can somebody get a question in like Buster, or are you going to give a thesis here?
I'm going to give you my third. I'm going to give you my third example of gravity.
Why?
Because
Why?
Have you? Because it may answer some of the questions that you have, and it'll.
The questions are about Blue's seismometer.
No. So,
yeah, that's why you came in here, triggered to fuck. That's what you came in here for.
Again, I was not triggered to fuck.
Well, let's get our understanding then of what's going on. Because Blue told us that you told him.
No, I didn't tell him. So if he said that, he was...
Anybody else that's here?
Did
I hear it wrong?
We're back to the point. We're back to the point where I don't think you're a reliable narrator.
Right. Well, I'm asking everybody else that might have heard it. Did I hear that PhD Tony was the one that told Blue to go and look into the seismometry or whatever, right?
That's not what I said.
That's what I heard. Oh, okay, because that's the impression I got from the video was that Blue had thought he might, maybe didn't really want to jump to conclusions.
Somebody told him, and I thought that was
PhD Tony. Tony said, "Yeah, that could be that earthquake." So he went and checked. I was like, "Okay, that's fair enough."
Yes, but I didn't. So there's a fine detail here. I said it could be the earthquake, and what Paige just said, Tony said it could be the earthquake. That's quite accurate. What Bev is saying is that I told Blue it was an earthquake.
Oh,
no,
that's right.
I didn't say that, and I don't
just
think
the
Blue
level
said
of
it either.
certainty that you said it with is all.
It's no.
You said it might be, not that it definitely was.
Yes, and that's an
that's what I said. So it's just the level of certainty. Yeah, sure.
Okay, I mean, when we're framing a scientific result, particularly in a field that my PhD thesis was about adapting a flat Earth seismic model to a viscoelastic framework for modelling surface deformation.
So you did model flat Earth
under surface load.
Nice.
Yes, I developed flat Earth models, and indeed flat Earth models.
Were you a flat Earther?
No, flat Earth seismic models turn out to be used very widely for mineral exploration. I talked earlier about I talked earlier about how we use seismic modeling and we try and work out where stuff is using the
and you said it wouldn't work on a flat plane. So why do they use it on a flat plane?
So the problem is that it doesn't work over large distances. It only works over short distances. So
the old locally horizontal.
How short a distance?
Okay, so anything more anything more than 2 degrees.
Just sneakily get that in the headline, won't we?
It's so. I mean, Paige, I'm a bit curious. Are you just calling me a liar now?
What?
No, the exact opposite. I'm saying you actually get it out in the first sentence.
Yeah, that was nice.
Right. Okay.
You model flat Earth models. Right?
I have done, but at the moment, what I do is
were they accurate?
They were accurate as to the. They were ultimately accurate, yes, but it's kind of a sad story, in the sense that
violins out.
The bottom line, we got asked to solve a problem. Basically, BHP Petroleum came around and said, look, here's where we found some oil, and here's the seismic data that we had before we found it. Could you have told us that the oil was there? And the answer was no. Just the characteristics of that particular field area meant that they thought they were seeing stuff at depth, but it was actually just random sound bouncing around near the surface, and every now and again there'd be sort of a resonant thing coming up. You didn't, because there were so many thin layers with highly contrasting properties. The sound waves didn't get deep enough to find the oil. So no, we couldn't have told them that the oil was there. But that's the way it goes. We were able to accurately model what happens in that area, though. And that's
so this technology is pretty reliable, pretty sensitive then, right? What you're talking about? Would you say that's the same technology they used in, let's say, the Russian borehole?
I don't think can you please specify which technology? The gravity technology, the seismic technology? Because the Russian borehole
flat Earth
was
modeling technology.
Flat Earth modeling technology. I wouldn't call it a technology. It's a theoretical treatment. But yeah, I mean, for for that you could pretty much model it as flat Earth. Really, I mean, I don't see why you wouldn't.
Flat Earth maps are often, it's just a projection. They're often useful. Like I use a Dymaxion map for anthropology.
Don't worry about it. All the surveyors do it as well. Like everyone's doing it. Don't worry about it.
So I wanted. So are there any questions about gravity? Like that mass attracts mass, and we know mass attracts mass because of the accuracy of Newtonian formulations when applied through gravity gradiometry, which is used in mineral exploration and it's used in ocean floor. Ocean floor navigation?
Can we call it vertical and say that it's perpendicular to the surface of?
No, we can't.
Oh.
Because the fact that gravitational acceleration varies from place to place means that the equipotential surface, what's called the geoid, is not actually flat. And so things fall at 90 degrees to the equipotential surface. They fall normal to that. They fall in the direction. That would be the definition of vertical. They fall in the direction.
And normal is perpendicular, right?
I think you're about to pinrose yourself.
Yeah.
Yes. So
that's exactly what I said.
So objects fall perpendicular to the geopotential surface, the equipotential surface.
So bindizontal.
No, he's not saying that. It's just saying it's perpendicular. Vertical.
Yeah.
Perpendicular.
Perpendicular to the equipotential surface. You seem to be ignoring that part. The equipotential surface is not vertical.
No, but it's perpendicular to the vertical. That's the perpendicular part.
It's perpendicular to the vertical at the point where the measurement is being made, yes. But it's not perpendicular to that vector everywhere, no. So the equipotential surface is not flat, right? it's got bulges and dips in it. And so things that are falling at 90 degrees to that surface are not falling towards the same point. And you can, and this is what gravitational gradiometry is all about, right?
Do you have?
I mean, it wouldn't work.
Do you have
right? If everything was flat,
what wouldn't work?
And by the way, the survey of the Bolivian salt flats also agreed with the geoid and the
equipotential surface. That's what you measure elevations relative to, is an equipotential surface or an estimate of the equipotential surface.
That's bendizontal.
Yeah. Do you have horizontals intersecting, or are they parallel to the plane of the horizon?
So this doesn't. That question is kind of meaningless, right?
No.
I mean,
it's a very simple question.
No, it isn't, because horizontal is horizontal,
or do they intersect? It's pretty simple.
Yes. So is how much does green weigh? That doesn't make it a meaningful question, right?
Well, you said
you can ask a question. You can ask a question that is both simple and meaningless. Again, I am calm. I am trying to talk over an interruption. Okay. You can have it that you are able to ask a simple question does not make that question meaningful.
All right. Well,
This is not your lecture class. We don't.
Geometrically, do horizontals intersect?
Define the term horizontals.
Like more than one.
Okay. Horizontal surfaces measured at the same point do not intersect. No.
Okay.
Horizontal surfaces from different points do intersect. Yes.
Wow.
In fact, I have explained this to you before, and you gave the same asinine response then.
Okay. Yeah, but that was back when you did the 500.
Yeah, and you didn't listen to me then, so you thought you'd ask the same question and ignore the response then.
3 angles at 180 degrees. That's what you said.
I did not say that. No.
Yeah, yes, you did.
I think you'll find that Team Skeptic was the one who brought up 3 angles at 180 degrees.
No, that was
you. I brought up.
No
there
idea
are 3
what
angles,
basic geometry is. Bev.
Each of which is 180 degrees.
3 angles at 90
Sorry,
degrees.
Tony, you said 3 angles at 180.
There are
idea
3
what
angles,
basic geometry is. Bev.
each of which is 180 degrees. What's 3 times 180?
An angle of 180 degrees.
Each of which is 180 degrees.
Yeah, you
did.
You fell into it. He did drag you into it. You're right about that.
My example would be, my preferred example would be 3-angled spherical triangle with 90-degree sides.
Yeah, he said
but anyway, you measure the.
I called you a flat earther. Yes, we have 3 angles of 180
That's
degrees.
a straight line, right?
I called you a flat earther. Actually,
I was pointing out your contradiction, Bev. I'm sorry, Tony. Go ahead.
You will recall that I didn't agree
angle.
with you. There are 3
what
angles,
basic geometry is. Bev.
each of which is 180 degrees.
You said 540.
180 is kind of a great circle. And I mean, that's a degenerate case.
Yeah, that's what I was saying. That's the best
straight line.
It's a straight line triangle that encompasses 540 degrees, which in actual fact is a circle, but you've got an extra 180 degrees because you've made a triangle out of it. You've done really well.
You're not. You're measuring in different dimensions, right?
Yeah, but you said 3 angles
360 degrees in a circle would be as measured perpendicular to the circle, and the 540 is a sum of 3 angles that are measured using in a very different sense, right?
Yeah, the great circle, like you said.
Yeah, it's a great circle. So I wouldn't really call a great circle spherical triangle.
You could add another line in there, couldn't you?
Any more than you could call a straight line a circle of infinite radius, right? I mean,
you could just keep adding kind of straight lines in it, couldn't you? Another 180 and another 180.
Well,
and another 180.
You could. You could turn it into a basically an infinitely dimensional polygon.
An infinigon.
An infinigon. But the central point that I was trying to get across. So the average person doesn't know about gravimeters, doesn't know how gravimeters work, doesn't know what gravimeters are, doesn't know what they're used for. You ever seen those maps of the Earth where we map the ocean floor? You may have noticed when you go down to the beach, you can't see the floor of the ocean. When you're flying over it, you can't see the floor of the ocean. So how do you think those maps are drawn? They're drawn using gravitational data.
LIGO.
There may be some using LIDAR, but that only goes so deep, right? There's a limit on how deep the LIDAR goes, and there's only a very small proportion of the Earth that has been mapped using sonar sounding or actual Bob measurements.
Can I just get it cleared up, Tony? Because Blue seems to think I was lying. Right, where is where I got lying and I got caught red-handed? Blue, what's going on?
What you said, Bev. Misrepresented what I said.
Go on then. What did we say, right, Tony? What did I say to you that got you triggered, Tony?
You said that I told Blue that it was definitely an earthquake.
Definitely? Was the word definitely in there?
Well, you didn't use the word definitely, no.
Okay, so you've added that in there.
That it was, okay. You said I told Blue it was an earthquake.
I heard that. That's what I'm sure that's what I got. I was checking with you. Did I put it as a question?
No. Well, sorry. At times you have phrased it as a question.
Okay.
Did you tell Blue? Did you in the chat?
Yeah.
Underneath you said, "Did you tell Blue?"
Yeah, yeah.
And then earlier on, you said Tony is the person who told Blue.
Yeah, that's what I thought. I heard.
That was an earthquake.
And that's
but you have been corrected. You have been corrected on this.
You did actually say that to him, right?
No, I didn't. I said it might be.
Well, there you go. That's good enough. That's
no,
similar.
It isn't.
Yeah, it is.
No, it isn't. If somebody says, if you go, oh, I've got a headache, and
I wasn't signing an affidavit, for fuck's sake.
If you go up to a doctor and say, I have a headache, and the doctor says, well, it might be a tumor. The doctor hasn't said you have a tumor. The doctor said it might be, right? We're going to do more tests.
Okay.
You get more information. Might be is not might be is not. I told him something. I said something was possible, or seemed possible to me. That is very different.
And
from
I was
me.
asking you, were you that man? Did you do that?
And that's what you did in the chat. But when you were introducing me earlier, you said I was the person who told Blue, and you've repeated that claim several times, and you've repeated the claim that that's what you heard. That you heard that I told Blue. Blue is here telling you that isn't what happened. I told you in the chat that isn't what happened.
Brilliant.
Right? But
so why is he saying I'm a liar?
Because you keep on saying something that is not true. You asked in the chat, but you repeatedly asserted here that it was a fact.
When did I repeatedly assert it here? That it was a fact?
I have already given you the examples. If you weren't listening, that's no skin off my nose.
You used definitely and then said, well, no, actually, Bev didn't say that.
You said, this is the person that told Blue that he detected an earthquake. No, I am not the person who told Blue. That is a definite claim that I said something that I did not say. I did not claim to say it. Blue did not claim I said it. And you said it after you had been corrected twice.
Okay, so
right?
can we put it on the record right now then?
When you've been told something is not true, stop saying it and people will stop calling you a liar, right? And for the record, if you want to impress me as somebody whose recall of events is reliable, do not tell me that you don't know what a spherical angle is when I took the time to specifically inform you what a spherical angle was in a chat that you responded to.
What? Right.
I told you.
Can we get this
what
clear
a spherical
then? Forget
angle.
about the spherical angle.
No, because that again is something you lied about. Because I came into the chat today and I said, "Do you know?"
Beginning to sound a little bit triggered.
No, yeah. I'm trying.
Let's get the first bit sorted out, right?
Again, but we're back to the fact that you're not a reliable narrator, right?
Well, yeah, I'm trying to get it cleared up.
You're a liar. You lied multiple times. That's why you're being called a liar. Stop lying, and we can move on. That's cleared up.
Can we get it clear then for exactly what happened? Right? To make it absolutely clear. Right?
Yes.
Blue notices something. Right?
Yes.
Somebody says something to him. Is that you? Or is it somebody else?
As I explained earlier in this conversation, no, it was not me. It was somebody in the live chat who pointed out that sorry, Blue, you can deal with that. But I did tell him that earlier in the conversation, and he's either forgotten or is pretending that I didn't say it.
You were shouting it, Tony, like you were like on a rant.
That should make
trying to
it
get you to
easier
calm
to
down
hear.
so we can understand what's going in.
Yes,
no, it's not
yes,
easy.
It's well known. It's well known that not paying attention to what people say and ignoring the words that are coming out of their mouth is a fantastic way to get them to calm down. Well done, Bev.
Right, so somebody says something to Blue, and then Blue says...
Blue said something to all the people who were listening on the live stream that morning.
Okay. This is new. And then you, at some point, decide to ask Tony. You decide to ask Tony something.
Exactly what I've been telling you.
You decide to ask Tony something.
The disturbance, I was curious and scratching my head thinking, what the hell's going on? And yeah, I said something like maybe it was a seismic activity. I can't think of anything else.
Right.
And then I noticed a couple of people had mentioned earthquakes, and somebody said, hey, maybe you had a local small earthquake or something. And one of the people in the chat, I could go back and pull all this. You can too.
Okay, I'm just trying to get the series of events in, so I'm not called a liar.
In fact, you can listen to me say all these things.
Okay. Right. And then you ask Tony something.
Oh, there's no activity, no seismic activity around you right now. Okay, fine, that wasn't it.
And you ask Tony something.
In this part of the country. Okay, fine, that wasn't it. And an hour and a half into it, somebody finally said, guess what they just reported on the news? 7.2 earthquake in Haiti at 8:29.
Yeah, we were brainstorming.
I sent a DM to Tony.
Right.
Said, here's what happened. Tell me I'm crazy. You can read it for yourself. Copied it word for word.
Okay, right. And then, so what Tony said then?
A 7.2 magnitude quake is pretty big, and the setup you've got is sensitive enough to feel it. Now, that's what happened. I'm making shit up.
So Tony told you what?
I said that I thought it was plausible, given what I knew of events, but that he should consult. Plausible does not mean true, but that he should consult with an expert. Did I not say you should consult with an expert?
Well, that's what I heard, and that's what I wanted to hear, right? That's all I could remember, because I don't know anybody else. I know PhD Tony, and I know when Blue said, PhD Tony said, whatever you just said, that's what I remembered.
Okay. And normally, if you misremember something, that's fine. People misremember things. They confuse the details. That's fine.
But I did remember it right? You did say something to Blue about the thing that happened, right?
I approached Tony, damn it.
Yes.
That's the
yes,
other way
you
around.
approached him, but did he say something to you about it after you'd approached him, Blue?
He responded to me. Yes,
right,
he
okay.
did.
Brilliant.
But
I didn't tell him
Tony
it was
is the one that instigated it. That's the fucked up story.
Who said that he was the one that instigated it?
Not what happened.
You're making stuff up in your own head.
All of us in the chat, for example, we were brainstorming because there was something going on, and I even suggested fracking. Who's I'm just looking at fracking in Tennessee, but no,
that was brought up. That's right.
Yeah, and then the news about Haiti started coming in.
Exactly what happened. It was a full hour and a half after the event before anybody found the news.
I can't remember saying anything about any timings of anything.
Tony is the one that suggested that I contact the USGS to get some confirmation of this. It took a while to wade through the USGS and find the right person to be talking to.
So Tony advised
you. That's the reason I didn't put out a video on it for 2 weeks.
Mm-hmm.
Wasn't going just based on what I thought or what Tony had said. I wanted to get something out of the USGS.
Okay. So could you really say that I'm a barefaced liar then?
Yes.
Yeah, because you're making it up in your own heads.
No, because words are important, mate. And there's a big difference between, there's a big difference between it seems likely and it definitely is.
Which I never said, and you admitted I never said it.
This is the guy who told Blue that it was an earthquake. That's what you said. And that's false. And you know it's false because I told you it was false before you said it. Multiple times, in fact.
Multiple times? You sure?
Yes, I told you in the chat. You asked a question in the chat below Blue's video. You said, "Are you the one who told Blue it was an earthquake?" And I said, "No, I told Blue it might be an earthquake, but that he should talk to an expert." So I answered your question, and you responded to that post.
Mm-hmm.
You responded to my post, so you read it. Just like you read the post about spherical angles before today, denying that you know what a spherical angle is.
There's no such
because
thing
you
as
responded,
a spherical angle.
I suggest again that you Google the term. A spherical angle is a dihedral angle between the planes coincident with each of the intersecting great
planes. In between the planes.
Yes.
Yeah.
Yes.
Two straight
lines. How spherical. Plane is not a line, right? You know that?
Yeah, it's a plane. It's a two-dimensional surface with zero curvature. Yes.
Yeah, so the spherical angle between two great circles.
Two-dimensional analog of a line, isn't it?
You can keep interrupting all you want, but you can Google it. It's on, they've got Wikipedia articles about angles, and you can read this up there. Or you can go and Google spherical angle yourself. Or you can look in any math textbook about spherical trigonometry. You can look up the spherical cosine rule if you want.
You've just said it's between two planes.
A spherical angle is the dihedral angle between the two planes coincident with the intersecting great circles.
So it's just a rectilinear angle.
No, well, a dihedral angle is separate from a rectilinear angle
between two planes.
Yes, it's the angle between two planes. No, it isn't, because there are multiple angles depending on the angle of approach you take between the two planes, aren't there?
Angle of approach. So you're introducing
If you
another
turn,
angle.
imagine two planes, right, that are intersecting. Take a protractor and measure the angle at 90 degrees, at right angles to the line of intersection. Now rotate the protractor. You're measuring a different angle.
It's just orthogonal.
Yes, the orthogonal angle is the one that you want, but there are in fact multiple angles between two planes. This is not complicated.
No, I agree.
Yeah. Okay, so a spherical angle is the dihedral angle between the two planes coincident with the intersecting great circles. I have told Bev this
it's just
now
between the two
5
planes,
times.
dude.
5 times.
You can draw circles wherever you want.
I've told Bev this 5 times. He can yet, and you heard him just a few minutes ago, he says that they're rectilinear angles. When they're not, there's a difference between a rectilinear angle and a dihedral angle. That's why we apply different adjectives to them. And he claimed earlier that spherical angles don't exist. I have given him a perfectly valid, mathematical, unique definition for spherical angles and how they are calculated. And indeed, if he even bothered to Google the term in the year and a half since I first talked. Again, if I'm really triggered, you'll be able to hear because I'll be yelling at you.
Like you did before.
And I'm not. Yes, that was a sample of what I sound like when I'm really, really fired up.
Wow.
Spherical. Now, in 18 months, Bev had not bothered to even Google the term spherical
You just
angle.
said between two planes.
Instead, he is. Yes, I said between two planes. It's a dihedral angle.
Yeah,
that's not a rectilinear angle. No, it isn't. It's a dihedral angle, and you can look up the formula for it if you're at all interested. But of course, you won't look up the formula for it, because if you were interested in actually doing any research on the subject, you'd already know all this stuff, because I gave you all the information necessary to find this theory, and you haven't bestirred yourself to go so far as even
Where would you use it?
You would use it on any calculation of, say, a heading. There's north. I want to go in that direction.
Just
I want the angle between them.
Just the azimuthal.
Yes, you have a tendency to throw out words in response to explanations.
Do you not know what an azimuthal angle is? Because that's the angle from
north. And questions that
right?
are completely... the azimuthal angle is the angle from north. Yes, that's right. Yeah. But that is irrelevant to whether or not you understood what I just said. I answered a question of yours.
You were talking about an angle from north. And I said the azimuthal as a question.
Yes. So
would that be a yes?
Here's how communication normally works. You ask me a question. When would you use it? I give an explanation of when you might use it, like when you're doing navigation on the surface of a sphere. That's when you might use spherical angles. And then your response is not to, that's when you would use it.
From north, and I said azimuthal.
Yes. Spoiler alert, I don't mean to rain on your parade, but I just checked and the Earth is a sphere.
Oh, did you?
And the angle from north is
a picture.
Is a spherical angle.
I'm liking this dihedral angle. It's like two planes intersecting.
Yeah.
It's awesome.
Yes, that's right. So
great.
So you take the planes incident with each of the great circles, right? And the dihedral angle.
Yeah.
Yes. Planes that are coincident with each of the great circles. Okay?
Yeah.
But planes.
Yes.
Okay.
Two different planes.
You know how a circle is a planar shape.
Yeah, but
no, I like the plane idea.
Which ones are the planes? Where are the planes? These two planes. Where are they?
They're notional mathematical constructs in this particular case.
Yeah. Where are they? Because we're doing navigating, aren't we?
Okay, so
where's plane one going to be?
Plane one is coincident with the first great circle.
North.
We've got two great circles. Yes, let's say north.
Okay.
And the second great circle goes in the direction that we want to go in.
Uh-huh. And these two planes are coincident, did you say?
No, each of the planes coincides with the great circles, right? Each of those great circles...
With their own respective great circles.
Yes, each plane coincides...
Now, a plane... Wait a minute, let me just check. A plane is a two-dimensional surface with zero curvature. And what's a great circle again?
A great circle is the it's the circle that has a center with the sphere.
Okay, so would the plane be tangent?
No.
Oh, is that because one's a straight line and the other one's a plane, and they can't be tangent to each other?
Because in order to coincide with the circle, it has to pass through the center of the Earth. Great circles, circles around the center of the Earth.
Oh, so the plane is with that in that entire plane of that circle, like a vertical plane.
If you insist on characterizing it in that fashion, I guess if you're careful enough about your use of the term vertical, you can use it that way.
Well, would that not be vertical all the way along that great circle?
I shall repeat my answer. No, it won't be vertical all the way along the.
I was just trying to
so the plane. So the plane doesn't have a direction, right?
I don't know.
Planes don't have directions. Planes
don't have directions, circle, right? It was pointing north.
Lines have directions. Planes do not, right?
Okay, so the plane that was on the north heading.
Yes.
Right, that would be a north-south plane then, right?
Yes, that's a north-south plane going through the center of the Earth, coinciding with the point.
Is that not north-south? Is that not a direction? Oops. I know what you mean.
No.
Yeah, I know what you mean.
No, and even that question is vastly more fatuous than you intended it to be.
Yeah.
So well done, you.
Well, I'm thinking you're just struggling because your great circle's actually a straight line, so that's why north-south seems okay.
I cannot help what you think.
Okay. So the great circle isn't a straight line now, then? It's a circle.
A great circle is a circle, hence the name circle. It represents the shortest. So the shortest path between any 2 points on the surface of a sphere will coincide to an arc along a great circle.
Yeah, and that's what you call a straight line.
No, that's not what I call a straight line. It's what I call it. No, it's not what I call a straight line in spherical geometry either. I would call it a geodesic.
Right. And can you have a tangent to that?
To what? The great circle?
Yeah.
Yes, you can have multiple tangents to the... but yeah, you can have a tangent to a great circle, yeah.
Well, that was what people called a tangent to a straight line on a curve.
Dear, what about your dihedral angles?
Yeah.
What about dihedral angles? What's wrong?
You got planes that are straight line planes, but you've got a great circle being a straight line.
I explicitly said that I did not call a great circle a straight line.
So wouldn't that be the shortest distance on that one?
Yes, and I call the shortest distance on a curved surface a geodesic.
Yeah, but what would you call the shortest distance on the plane?
The shortest distance between 2 points in a general three-dimensional setting is a straight line.
Okay, and that's the same or different?
As what?
As the shortest
geodesic
distance. Yeah.
The short. It's different from for any curved surface. A geodesic is different from a straight line because you're constrained to move within the surface.
Team Celtic said they are infinitely small straight lines, though, right?
You can approximate them mathematically in that fashion, yes. But in point of fact, there are no 2 points. But that's an approximation, and in the limit, it becomes accurate.
There are no 2 points, did you say?
There are no 2 points on the surface of a sphere that can be connected by a straight line that coincides with the surface of a sphere.
Yeah, because there's no straight lines on the surface of the sphere.
There's no straight lines on the surface of a sphere, right?
Yeah.
Yes. So no,
so
I
it
did
can't
not
be
say
you don't think it's a two-dimensional surface, even though you've just said you can't have a thing on a plane, because a plane's a two-dimensional surface.
I don't. When you say it, what are you referring to?
I'm talking about like the straight lines, because you've just said you can't have a straight line, or there's no 2 points that can coincide with the plane and the surface of the sphere, because
no,
the
that's
surface
not what
of
I
the sphere
said.
is a surface
that's
of constant
not what
curvature.
I said at all. That's not at all what I said.
Okay, so do you think you
what
can
I
have...
said?
Go on.
Can have what? Finish your question.
The 2 points of a straight line on a plane coinciding with the 2 points on a sphere.
Yes, trivially.
Trivially.
Yep.
Okay, is that like a yes or a no?
I did say yes, comma.
And then you qualified it trivially. What does trivially mean?
Any 2 points
I'm not aware of that.
Any 2 points can be connected by a straight line. In fact, that's one of the definitions of a straight line.
Okay.
Is the locus of points.
There's a difference between the surface of a sphere and a two-dimensional plane.
Yes, there is.
Okay.
Were you expecting more?
Well, it's just that we've heard some people say that the surface of a sphere is two-dimensional.
It is.
So there's a difference between two-dimensional and two-dimensional.
No, you can have two-dimensional surfaces of multiple geometries depending on how you define dimension.
But with
multiple
different
geometries?
With different, completely different straight line distances.
So do you know what a dimension is? Do you know what the dimension of a space is?
Oh yeah, I know the 3 dimensions. X, Y, and Z.
Okay. No, you don't know what dimensions are. Do other
so
people
you're
in the
telling
chat
me
know
X,
what
Y, and Z
are?
aren't the 3 dimensions that we use?
To be actually X, Y, Z, and T would be required to define the space-time because we exist
time's
in space.
not a dimension. We're just dealing with the 3 Euclidean dimensions, right?
So yes, but
you just
that doesn't mean you know
tossed something in there and said, "There you go."
No, because we live in space-time, right?
Right?
You might do. I just live in 3-dimensional.
Einstein demonstrated that we exist in space-time. Time is not actually independent from space, right?
Right.
Well, do you agree or not?
What?
Is this the point where you want to ask a stupid question, or are you willing
just keep
to accept
going, dude?
that okay? So
that isn't an acceptance. You just keep going.
Mathematically, the dimensions of a space, which is a set of points, is the number of vectors or variables that you need to uniformly identify your location within that space, right? That's what a dimension is. Actually, I'm not sure why I'm asking, right?
X, Y, and Z. Yes, we know.
No, you don't, because on the surface of the Earth, for instance, you only need latitude and longitude to uniquely define your location on Earth.
You need an elevation marker with Z.
Yes, and that is all you need.
X, Y, and Z. Yes.
Are you going to shut up?
Just telling you that we know what you're talking about and we're with you. Yes.
Okay.
You stop treating us like we're children.
Okay.
80% of the talking.
So the question, you expressed dismay and confusion that a sphere is a two-dimensional object. I just demonstrated mathematically.
Dude, did you just say a sphere is a two-dimensional object?
I just demonstrated why it's a two-dimensional object because you only need
a circle is a two-dimensional shape.
You only need
a square is a two-dimensional shape.
You only need two variables to uniquely identify a location on the surface of a sphere.
No.
Yes.
No.
You only need your latitude and longitude.
A circle is a two-dimensional shape. A sphere, you're not going to say is a two-dimensional object, surely.
The surface of a sphere is a two-dimensional object.
Oh.
No.
Yeah.
Yes.
Yes.
Wow.
We've been telling you this forever, Bev.
A two-dimensional object, though, right? That's ridiculous.
He invoked a fourth dimension of time, but now he's saying a sphere is two-dimensional.
I'm saying that the surface of a sphere, and again, this is a mathematical construct. The surface of a sphere is a mathematical construct. It doesn't exist physically, whereas the Earth does.
A sphere does, though, right? A sphere exists in three-dimensional Euclidean space. Its surface definitely exists, right? So the one that you're talking about is a figment of your imagination, whereas the real sphere is a real thing that exists in three-dimensional Euclidean space and has a three-dimensional surface, making up that surface.
You can uniquely locate every point on the surface of a sphere with two variables. Latitude and longitude, or co-latitude and longitude.
That's two dimensions.
I mean, I appreciate that you guys don't believe it, that it doesn't make sense to you. Fine.
Two dimensions is fine. I can go in a house and measure one wall and another wall and get the square footage. No problem. Conceptual.
Yep.
Get the square footage. It's 2D. It's conceptual.
Yes.
The surface of a cube is also 2D. The surface of any solid object is not a solid cube. It's not a solid sphere either, if you're talking about the surface.
It just gives me the square footage to use it practically.
The surface of an n-dimensional object has dimension n-1.
Yep.
Right?
Yep.
It's that simple.
Yeah, that's surfaces. How many surfaces has a sphere got?
One.
And you think that's two-dimensional?
Yes, it is. I mean, I'm not clear why you think, clearly you think this is some sort of gotcha moment. You expressed dismay and confusion that a sphere is a two-dimensional object. And I'm just explaining the mathematics.
All of this with us, everybody, Tony, right? It sounds fantastic to me. It still does.
Okay, so do you can I just suggest, look, if you can being able to name the traditional notation for Cartesian coordinates, three-dimensional Cartesian coordinates, doesn't mean you know what a dimension is, right? Any more than the fact that you can name a character in Game of Thrones allows you to understand the finer plot points. It's just not the same, right?
What's that?
So yeah.
What's that?
Let's just leave
the character
as,
from where? I can definitely do the
matter.
Cartesian XYZ.
Yes, but you cannot explain what dimension.
What's that other thing?
I don't. It was a frivolous example, and I should have known better than to assume you're literate.
Length, breadth, and thickness. Those 3 dimensions, or length and breadth for the 2, and then length, breadth, and thickness for the 3.
Length and breadth are the measurements of a 3-dimensional rectilinear solid.
Length and breadth would be
they can also be on a 2-dimensional.
No, you gotta say that again.
So length and breadth are 2 of the dimensions of a 3-dimensional solid, a rectilinear 3-dimensional solid, or they are the 2 dimensions of a rectilinear 2-dimensional shape.
Yeah.
So what was the point of getting me to repeat that? Was it not clear enough the first time around?
That was cool. Thanks.
Okay. So we've covered today the absolute fact that we can experimentally verify that downward acceleration and the movement of mass towards one another obeys Newton's law of gravitation, because if it didn't, gravity gradiometry would not work, but it does work. We can tell that mass attracts mass because gravimetric mineral surveying works. We can tell that mass attracts mass because gravitational mapping of the ocean floor works. So we know that gravity is real and that it obeys Newton's law of gravitation in macroscopic non-relativistic frameworks, such as the surface of the Earth.
What's your favorite color?
I'm assuming that had some relevance to the conversation, but I'm struggling to see what it was, so I'm going to continue as though your contribution does not exist. So, is there anybody present who is willing to present an argument that gravity does not exist or that it does not obey Newton's law in macroscopic non-relativistic frameworks?
Would you call it vertical? I think we did this before.
Yes, we did, and I answered that question previously.
Would you call the vector vertical?
The vector of what?
Your gravity.
There's no such thing as my gravity. There's only gravity.
Right.
Yep.
Would you call it vertical?
Ask the question properly.
Would you call it vertical?
No, it is not. It is not a vertical word.
Then
vertical.
It's not a vertical word. What is that?
Hold a plumb bob. Would you call that a vertical? Would you call that a tool for establishing a vertical?
Yes, I would.
Right. Now, would you associate that with gravity in any way at all?
Yes.
Right, okay. So would you call the vector of gravity vertical?
There you go. You happy?
What?
I've answered all your questions. Do you have any other questions?
I don't think I heard an answer then.
I said yes.
Okay, brilliant. So vertical is a go, right? We can just stop using gravity And just use vertical.
No, because vertical contains no the concept of vertical is an entirely local element that changes as you move, because gravity changes as you move, and we know that because we can measure the rate. We can measure that the rate and indeed, well, the rate at which things fall and indeed the direction in which they fall changes as we move.
Vertical stays vertical, though, right?
Vertical is entirely local. As soon as you take one pace in any direction, you are talking about a different direction.
Yeah, so does your gravity. It matches it, right?
Yes.
Okay, so there's no difference then?
It
can't be a problem for vertical if it's not a problem for gravity. If they're both exactly the same and they happen to be exactly the same.
There is very much a difference between the two, in the sense that gravity has a vast amount of research and literature associated with it, while verticality, vertical does not.
What? People haven't studied vertical.
Yep.
Oh dear. It's just a straight line, though, really, isn't it?
No, it isn't. It's
not
multiple
just a straight
lines. No,
vertical's not a straight line.
Yes, vertical's not a straight line. Vertical, because it's different when you move to different places.
Still a straight line there, though.
It's not a line, right? It's not just one line. It's only one line if you're standing.
Vertical is not line?
No, it isn't. Unless you are restricting your attention to one point. Right?
What?
So in order to have any generalizability, so vertical at one point is not the same as vertical as another point.
Yeah, but how many times have you ever held a plumb bob?
Several.
Right, now, whenever you use that plumb bob, where were you?
I can't remember.
Right, did you only have one?
Yes.
And was it establishing a vertical at that time that when you used it?
Approximately, yes.
Every time?
I didn't take. Yes, approximately. It was establishing a vertical at the point where I was applying it.
Yeah,
but that vertical was different from all.
You use the plumb bob, right?
Yes, but that's different. But that's different. For different areas. The Schehelian experiment, for instance, established that plumb bobs drape slightly to the drape slightly away from the dead azimuthal due to mass being off to the side.
What? Well, yeah, but what was it that they established that with, right?
It was with a plumb bob. Well, they measured
so they
the
put
azimuthal
the plumb bob down, right, and it was vertical.
They measured the azimuthal relative to the stars overhead.
Oh, right. So
very precise
the plumb bob was hanging
overhead.
in what it would normally be vertical, but somebody decided to go, hey, that star up there doesn't look like it's in the right place. I guess that vertical with the plumb bob mustn't be vertical.
Instead of speculating about what these people did, you could go and actually read the description of the experiment.
Yeah, that's what they did. That's what they did. They hung a plumb bob and looked up at the lights in the sky and went, it might not be vertical.
It's a good thing we now have vastly more accurate instruments, isn't it?
Yeah. They do it again then? Are they doing it again?
I think they did do it at the 200-year anniversary, actually.
Right. Looked up at the lights in the sky.
Yes, and now
is that what they do? Check the almanac, get the GP.
The thing is.
Or did they do it at the North Pole?
Okay, the thing is that scientists, fully qualified scientists, who hold degrees and published papers and submitted their work for peer review. They did this work, and they their results have subsequently been validated by lots of other independent experiments using different methodologies and different tools. So your claim that they did it wrong has been demonstrated to be false.
You said they did it wrong.
You did.
No. What they did was they held a plumb bob, as you would normally
results
do,
have been validated many times
and
since.
then they looked at the lights in the sky and went, "Ooh."
I don't care how you choose to characterize it. The results they obtained have been subsequently validated many times.
Must be the same way, right?
No,
hanging
using
a plumb bob and they're looking at the lights in the sky.
No, by you seem incapable of understanding what I'm saying.
You're saying that the vertical of a plumb bob wasn't actually vertical.
No, that's not what I'm saying.
Yeah, it is. A mountain deviated it off vertical. They measured it by looking at the lights in the sky. That's what you said.
Okay, what I am saying is
that's
that the mass
what the experiment is. I've checked it.
It would be easier for me to explain what I said.
Go on then.
If you would let me do it.
Have a go at explaining the Schehalian, the whole thing.
Okay, so you determine you can determine which stars are overhead at a particular location using a plumb bob far away from any mass, right? If you got
at a particular time,
yes, at a particular time, if you are accurate enough in the way you undertake the measurements. Having established that this is vertical at that point, that this is the direction that the plumb bob hangs, you can move your apparatus closer to the mountain, and you can observe whether the plumb bob makes the same angle with the star overhead at the appropriate time. And if it doesn't, you can tell that the trajectory of the plumb bob has deviated from the trajectory to the star, right? The plumb bob is still hanging in the direction that is defined as vertical, which is to say in the greatest decrease of gravitational potential. But its relationship to the vertical line towards the star has changed. So you're trying to use vertical in two different senses to describe both vectors.
Yeah, vertical's just vertical. To me.
Well, you can continue under that misapprehension as you prefer. I have made every effort to explain this in a clear and concise fashion, and if you are incapable of understanding my explanation, then that's not really my problem anymore. But getting back to my question, does anybody here wish to dispute, have any inclination to dispute the existence of gravity and the fact that it obeys Newton's law of gravitational attraction in a macroscopic non-relativistic framework?
Dude, you've just wobbled vertical around. Like, who's going to argue with you with anything?
So you are denying the efficiency and the existence of gravimetric mineral exploration.
No, I'm not denying your sophistry, mate. You've just wobbled a vertical right in front of our eyes. Told us that vertical isn't vertical. I've confused the two verticals.
Yeah, I was okay with like bendizontal, but you like totally curved a vertical. That's first I've heard of that.
Okay, would any of the sane people like to decide? So you want to join him in Dunn's class? That's fine.
Well, I would say the person who's trying to argue without any success and continues to do it over and over again should probably get the dunce hat themselves.
I'm not arguing. I presented material. You guys haven't done anything.
So you're not going to address my point. That's fine.
Which is what? What's your point?
Why don't you say back to me what I said to you?
You said that you think that the person who is arguing the same thing over and over again should get the dunce hat, not anybody else.
Right.
Close enough? Okay.
Yes, the person I'm not arguing. Ineffectively.
I'm obviously not arguing
again without any success.
I'm obviously not arguing. You see, success, because you aren't presenting any counterpoints. None of you are presenting any counterpoints. None of you are saying we can explain away gravity gradiometry this way, or we have another phenomenon that will explain gravimetric mineral exploration, or we can map the ocean floor using some other phenomenon than gravity.
Well,
right?
What if just possibly your sophistry has rendered you an unformidable opponent and we don't give a shit what you have to say?
Then it would be a feeling that is entirely reciprocated.
Which makes me go back to my original point. Why are you wasting your time if we are the losers?
Because it makes me feel good to make you guys aware that you're losers. Because it makes me feel good to make you guys aware that you're losers. Because it makes me feel good to make you guys aware that you're losers.
If you enjoyed the content, please support On the Level and future projects. Membership subscriptions available now, or come and get involved at Next Level Discord server. Thank you.